Hello and welcome. In lecture number 2, we will be dealing about chapter number 2 of this book, which deals in entity relationship model. We had a brief discussion about the entity relationship model, which is modeled by the entities followed by the relations with other entities. So today we are going to be taking a broader look into this ER on the entity relationship model, just to see the different aspects. So, as an overview of database design, we can always deal with the conceptual design, like I talked before. And for the conceptual design, like I stated before, we use the ER model or the entity relationship model. We can use many models for the conceptual design, like the network model or the hierarchical model for that matter. But one of the most popular models is the entity relationship or the ER models. And like we have discussed before, we are mainly concerned in this model with the number of entities in the system and the relationship of these entities with other entities, hence the term entity relationship. We are also concerned about the information about these entities and relationships that we should store in the database. This is precisely given by the term fields or attributes of the entities and the relationship. So, any fields or any attributes of the entities and the relationships we should record in the ER model at the conceptual design level. For example, revising like before, as a student, as a student entity, your attributes might be student ID, student name, GPA, address, etc. One important point that should be considered also at this conceptual design level at the ER model is the integrity constraints or business rules that hold. Well, I told you that there are integrity constraints, there should be integrity constraints because data need to be consistent. Data should not be consistent, data should not be anomalous. So, to remove and to avoid data anomaly, there must be integrity constraints that would make sure that data remains okay, data is not anomalous, data is not bad, the data is consistent. So, the main use of the integrity constraints is to have the data consistent. And of course, these business tools can also hold, and they sometimes just refers to the integrity constraints. And the conceptual database schema can be represented in an ER diagram, like we discussed before, right, and like we drew before. So, ER model design can be represented by an ER diagram, and the ER diagram can be mapped into a relational schema. For example, when we make the SQL tables, right, it would be the ER diagram would be easily mapped into a relational schema that can be implemented by SQL. Let's look at some ER model basics now. So, what is basically a relationship, right? So, relationship is an association among two or more entities. So, relationship can be between two entities, like works in is a relationship between employees and department's entity, and works in is a relationship. So, then based on these things, for example, Atishu works in pharmacy department. Atishu is an employee and he works in the pharmacy department. Then a set of all relationships would be called as a relationship set, which would be a collection of similar relationships. Thinking in terms of the database or the model, we can say that works in would be a table, and all the entries that would be stored in the works in table would form a collection of relationship called the relationship set of works in, or in other words, works in relationship set. So, works in relationship set contains the rows that represent the relationship of employees working in departments, and it can be an n-array relationship which would relate to entities with the relationship. So, these are two entities. So, this is a binary relationship because this is entity 1 and this is entity 2, binary 2. There can be ternary relationship. if there might be some relationship that might be having a third entity participating also. So they would be definitely termed as ternary relationships. But in most of the designs, we usually have those binary relationships. And the same entity could participate in different relationship sets or in different rules in the same set. For example, employees is the entity and reports to is a relationship. So supervisor is also an employee and subordinate is also an employee. So it is basically a unary relationship, because this relationship is between a single entity which is employees. These things that have been shown in circles are the attributes. So when we talk about employees, the attributes of the employees is the social security number, name, lot. The attribute of works in is a since field, and for the departments, the attributes are department ID, department name and budget. Then we can look at key constraints, and key constraints are very important constraints, and we can consider in the works in relationship. Now looking further at the key constraints, we can see in the diagram, right, it is a 1-to-1 constraint. This is 1-to-many constraint. This is many-to-one constraints. This is many-to-many constraint. Let's look at it in detail. Let's look at in works in relationship, right? First of all the entities of employees is participating in this works in relationship, yes or no? Because there are no blank things, all the entities are participating. So we have total participation from employees in the works in relationship. Similarly, when we look at departments, all departments are participating in the works in relationship. So again, total participation. So this is one aspect. Let's look at the other aspect. Now let me, yes, here put the mouse pointer as a pen. Now one employee can participate in or work in many departments. This employee worked in this department on this date. This same employee worked on this department in this date. So 1-to-many from the point of view employees and department. So we can write 1-to-many. Now let's look at from the department side to the employee side. What is the relationship? 1-to-many, 1-to-many. So we write 1-to-many. Combining those, we have a many-to-many relationship. So hence it is written works in has a many-to-many relationship between employees and departments. Now let's look at managers, right? Total participation or partial participation? Total participation, right? Over here also total participation. Now one employee can manage many departments. So from the point of view employees, we have 1-to-many relationship. Now one department is being managed by one employee. This department is managed by this employee. This department is managed by this employee. So from departments, one department is managed by one employee. So it's a 1-to-one relationship. Combining these two, we have a 1-to-many relationship, and the same has been shown over here. Also note that employees have the partial participation in managers. Why? Because this employee was not selected as a manager, so this entity is not participating in this. On the other hand, departments again have a total participation. Why? Because every department must have an manager. So this is one of the important things. Now we can have another aspect which is called a participating or participation constraints. So does every department have a manager? Does every department have a manager? Yes, because this department has got this manager, this department has got this manager, and this department has got this manager. So if this is the case, yes, this is the case, it is a participation constraint. So the participation of departments and managers is said to be total versus partial, or we can also say total or full participation, right? So what does this mean basically? This means that every DID value in departments table must appear in a row of the managers table with the non-null SSN value. Now students, please try to create the managers table, write the fields for the managers table and the data for the managers table by using this particular entity that I have shown, this one, right? Create an SQL table, write the fields and write the data in that SQL table. So what can we do? We can have something like managers, right? Managers would have a department ID, which would represent this department, and it would have a SSN, which represents an employee. And then we'll have the since attribute, so we can start to fill the table, right? This is the managers relation. 51 is managed by 231. Since 3393. Then we can have, please complete this table. 56, 56 would be right 231. And 2292. Then 60 would be 223. And it's 3192. So we can see this is basically the table, right? So every DID must be in this manager relation with a non-null SSN value, because every department must have a manager. Okay? So what we can do, we can sort of see that first of all, this is the ERD or the entity relationship diagram. Employees have a partial participation in managers, right? Like we discussed before, because all employees may not be managers. So we have a thin line, but all employees have the total participation in works in, so thick line. Again, departments have got a total participation in works in, so a thick line. And of course, departments have a total participation in managers also, so again a thick line. And based on this particular thing, that every department ID must appear in the managers with a non-null SSN value, since we have this thing, we also have this arrow from the department side towards the managers side, and this can be further seen by this thing, right? Every department ID is participating in the managers relationship, so this particular arrow. So this is how the ERDs actually work. Now, after having considered about the participation constraints, we can move on to another point which is called as the weak entities. So they are the strong entities and they are the weak entities. So what is a weak entity? A weak entity can be identified uniquely only by considering the primary key of another owner entity. So, and the classical example can be employees dependents or dependents of an employee. Now dependents would be weak entities when considering an organization, because organization is not really concerned about the details of the dependents, and each dependent being a weak entity would be identified definitely by a employee's SSN, and one employee can have many dependents, or one owner can have many weak entities. So as we can see, there's a policy relationship which is basically an insurance policy for the dependent that is created by employee. So employee has a policy about dependents, and basically the weak entity being identified by the employee's SSN, and one owner can have many weak entities. Then we can think of the is-a hierarchies, and is-a hierarchy basically deals with attributes which are inherited, right? So in this example, hourly employee is a employee and contract employee is a employee. So hourly employee being an employee would inherit the attributes of the employee, and some new attributes would be added to the hourly employee's entity. Similarly, contract employee would inherit the attributes of the employee with one particular specific attribute like the contract ID. So now when we talk about inheritance and other things, we can think about constraints, overlap constraints and covering constraints. What are overlap constraints? Can an employee, for example Joe, be an hourly employee as well as a contract employee entity? We'll have to see whether it is allowed or disallowed. And there can also be covering constraints. Does every employee entity also have to be an hourly employee or a contract employee entity? Yes or no? Can employee be just an employee, not an hourly employee and not a contract employee? So this would be called covering constraints. So what are basically the reasons for using is-a hierarchies? To add descriptive attributes specific to a subclass. So these two attributes were specific to hourly employees, so this would be added only in this particular entity. Similarly, this particular attribute is specific to the contract employees, so it would be added to this particular entity only. And we can also use it to identify entities that participate in a relationship. Now we can look at another important aspect which is called aggregation. And aggregation is used when we have to model a relationship involving entity set and a relationship set. Let's look at this scenario. Projects are sponsored by department, or departments sponsor projects. Let's say we want an employee to monitor this sponsorship, right? So in order to do that, we'll aggregate these entities and relationships, and then monitor would monitor this entire aggregated resultant entity that has been there. Now the employees can monitor this aggregated entity which is called sponsors. So aggregation allows us to treat a relationship set as an entity set for the purpose of participation in other relationships. So this was the relationship set, and we are treating it as an entity set so that we can do this, the monitoring with employees. We can also have a ternary relationship, and we can make sponsors and as ternary, and we can combine that, right? So we'll look at this in further example. Also can say that each sponsorship is monitored by at most one employee. The one employee would monitor at the most this particular relationship, sponsorship, and this is the until, which tells us for how long the employee would monitor this particular relationship. So when we are designing using conceptual design using the ER model, there are certain choices we can have. And what are these design choices? Should a concept be modeled as an entity or an attribute, right? So the answer to this is, it depends on the importance of that thing. If we have an entity, or if we have an object that has got multiple attributes, so we would model it as an entity, of course. Should a concept be modeled as an entity or a relationship? That again depends on the business semantics. Like for example, teachers and students. So teacher is teaching the students. So teaching definitely comes out to be a relationship between teachers and students. And then we can identify the relationships, whether they are binary or ternary. And do we need to use aggregation, and so on. And this constraints in the ER model. A lot of data semantics can and should be captured. One of the prime aspects of ER modeling is that the constraints or business rules or data checks that we provide in the ER model should be such that data can be captured and data can be entered easily. If the constraints or the rules that we choose act otherwise, making data entry difficult, so it is not a right design that we did. But some constraints cannot be captured in DR diagrams. So we will look at some examples later on also. So entity versus attribute. Should address be an attribute of an employee or an entity connected to employees by relationship? This decision, everything on it, depends upon the use we want to make use of the address information and the semantics of the data. What are the examples? If we have several addresses per employee, address must be an entity. Why? Because attributes cannot be set valued. Attribute has a single value. Attributes cannot have a range of values. So if we have multiple addresses for an employee, each address must be modeled as an entity. And also if the structure, city, state, etc. is important, we want to retrieve employees in a given city, address must be modeled as an entity. So if address is modeled as an entity, we can search and we can have many granular approaches towards finding a certain information in the address. For example, all employees living in Gulshan Iqbal, all employees living on Tariq Road, etc. So all of these decisions would definitely depend on the organization and the data usage of the organization. So when we are designing a database, we meet the employees, the stakeholders of the organization, and have detailed discussion with them just to find out what is the data, what is the meaning of the data, and how that data is used. So now we can have another example of entity versus attribute, right? We have a works in 4 relationship, which is a relationship between employees and departments. Now let's create the attributes and write the attributes of the works in 4 relationship, right? So what would be the attributes? SSN, DID, and from to. Now this is SSN and DIDs both are underlined, right? So both being underlined means that the for each row the combination of these two should be unique, or these two are used as primary key fields in the works in 4 relationship. Let's say employee number 10 works in department number 20 from duration A to duration P. What if employee number 10 works in department 20 from duration C and from duration D. What I would do, I would write 10, 20, C and D. But in fact I cannot write this. Why? Because this combination must be unique because of this SSN underlined and DID underlined. So the combination is repeating. So I cannot add this row to the works in 4 relation, which means this design is making it very difficult for me to enter data into the works in 4 relationship. So it's not a good design. Let's look at the bottom. Now in bottom we have now a ternary relationship, right, between employees, departments and duration. Now duration has got a from and a to field. So what we can write as a format for this works in 4 underscore 4 second version. Now when we work on the second version, what would be the fields be? This field would be SSN, DID, SSN, DID, from, to. But the difference would be now all these 4 would be underlined, meaning now this in the works in 4 relationship, the combination of these 4 has to be unique. So this row now would become acceptable in this particular diagram. So we should be very careful when we are modeling so that data is easy to add into our design. Again, another note about entity versus relationship. Within employees, and this is manages to relationship between employees and departments, where the first year diagram is okay if a manager gets a separate discretionary budget for each department. If the employee gets a different budget for each department, these different values would be stored with managers, so it is okay. But if the manager is getting a single budget to be divided amongst the departments, this department budget field would be repeated and it would be redundant, causing problems in the manager's relationship. So if it is the case that the manager is getting a single budget for all the different departments, it can be done something like that. So employees is a manager or manager is an employee, and manager has got a departmental budget and it is participating in the managers to relationship with the departments. Now what is the beauty of this approach? Now this department budget would be stored with the managers. Now single entry would be made over here, so there won't be redundancy or repetition of this departmental budget, and this is the same thing that we wanted. So this definitely fixes the problem. So summary of conceptual design. Conceptual design follows a requirement analysis, yields a high level description of the data to be stored. Again, conceptual design should aid in the storage of data, it should not hinder the data. So ER model is popular for conceptual design. Constructs are expressive, close to the way people think about their applications. What are the basic constructs? Entities, relationships and attributes. And attributes are of course the entities and relationships. Some additional constructs may be there. Weak entities is a hierarchy, is aggregation. Note there are many variations on the ER model. We'll look at them as we progress. So several kinds of integrity constraints can be expressed in the ER model. Key constraints, participation constraints, overlap, covering constraints for is a hierarchies. Some foreign key constraints are also implicit in the definition of a relationship set. Some constraints, notably functional dependencies, can also be expressed in the ER model. We'll look at that later on. So foreign key constraints have been mentioned, right? Just to give you an idea, let's say we take a very simple entity and relationship, right? employees manages departments, right? So employee is the primary key. SSN is the primary key in employees because SSN is underlined, and SSN must be unique for in each employee row. Similarly, department ID is the primary key in departments because it must be unique for each department. But in managers, we'll have the SSN, which would now be a foreign key in managers. Similarly, DID would be there in managers, and DID would be a foreign key in managers. And for that matter, we can say the combination of SSN and DID would be a primary key in managers. Combination of SSN and DID. So this is some points. So constraints play an important role in determining the best database design for an enterprise. So please students, be very careful in implementing constraints, because wrong constraints can make data entry and deletion very difficult in a database. So this is one thing you would focus on a lot.